Welcome back everyone to another episode of the Doom series, and in this video we are going to learn how to actually map the wall textures onto the wall surfaces in our 3D world. So I'm going to begin by, first of all, we're going to open up our renderer.c and renderer.h. We're going to open both of those. So inside of here, there are a number of things that I have changed. So first of all, now that we want to render wall textures, which are individual textures inside of texture arrays. So inside of our fragment shader, we have got along with a usampler 2D array, which I have renamed to texture array. We have got a single usampler 2D texture called texture here as well. And what we do is that we allow this texture. So if our texture type is 0, we have got just a plain color. If it's 1, then we fetch from the texture array, and if it's 2, we fetch from the individual texture, and we use that. So of course we just have vector 2 texture coordinates here, and we can just fetch that directly and pass it onto our palette. So this is the basic way it will work with our kind of 3D texture and 2D texture separately. So we are going to go here, and the other thing I have changed is that now inside of render.h you can see there are two functions. One is for setting just the draw texture, which is the individual texture, and one is for setting the draw texture array. So for setting the array, we just set the active texture to texture 1, and then we bind the GL texture to the array to this texture. And for the other one, which is the draw texture, we use texture 2, which is going to represent the plain texture, and this time we don't bind GL texture to the array, just GL texture 2D. And apart from that, in our init function, we of course assign the texture array location to 1 for our text array variable, and for just the texture variable, we assign that to 2. And those are the only things we change. And now we can go ahead and take a look at another thing, which is that in our gl helpers.h you can see we have got our generate texture here. Well, I'm going to open up gl helpers.c, and in here earlier when we were previewing, we had changed this to use gl texture to the array with just a size of 1 on the z-axis. Well, now we are not going to do that anymore. We can just use a plain 2D texture. We are going to remove changes from texture to the array. Earlier it was like texture to the array, we have changed this to texture 2D, and instead of gl text image 3D, we are going to change this to 2D with these arguments, and that's going to work quite well. And now the next thing we need to do is we need to actually load the texture information from our WOT file. So if I open up map.h, you can see in the side def I have added two new variable, actually 5 new variables here. There are two signed integers called the x and the y offset respectively, which represent how much it's offset on both the x and the y axis. And we have also got 3 integers which are upper, lower and middle, and these are actually indices into our array of textures. Now the Doom WOT format stores these as strings or actual names of the textures, but we are going to use a texture array to calculate the indices, and we are going to store that. Upper, lower and middle are 3 textures. Upper and lower are for the two-sided line tests, the ones that you can see through, while middle is just for one-sided line test. We are going to start with one-sided line test in this video, but we are going to add everything for the sake of completeness. And if I go ahead and open up actually WOT.h here, you can see that let me close these. So you can see that in here we have changed the signature of our WOT read map function, and this function now takes an array of wall textures along with the number of textures. And the reason we need this information is because we need this to kind of figure out the appropriate indices for the side def textures from this array. So currently we'll use a linear approach. We could use a hash map, that would be more efficient, but right now for simplicity we are going to just since we are only doing this once, we can just go over each of the texture and find the correct index and store that in our side def. So I'm going to open up WOT.c here. Now in here the main thing that we change is that you can see that if I go down here, you can see that where we are reading our textures, one important thing that I do is that I use memcopy to actually copy the texture data, where our texture lumps, texture data starts. The first part is the first 8 bytes represent the name, so we use that to copy that into the texture's name. And if I open up wall texture.h, you can see we have added a array of 8 characters here which represent the texture's name. So we basically copy those 8 bytes here. This is always guaranteed to be equal to 8 bytes exactly, so we can just safely copy that into our texture's name. And for the read sides function, the private function that we have for actually reading the sides, we are going this is the one that's going to actually use the texture array and indices, and in here we pass our array and indices to this function like we were we are supposed to. And when this function, inside of this function, the thing we change is that in here you can see that we loop over all of our textures. So we do that 3 times. So we loop over each of the texture and we compare the texture's name to this, and we use the lump data, we cast that to a character pointer, and we add I, of course, which is the actual index for this this particular side def, but we add 4 because that is the index where the first upper texture name is stored. And then we just compare that with the texture name, and we use string and compare. The reason we use that is because we want to compare exactly 8 bytes, not more, not less. So we're going to compare those. If it's equal to 0, which means they are equal, then we are going to set the side as upper value to k. Otherwise we are going to go here and we are going to set its lower value to k, and this time we are going to use offset 12, and the next time we are going to use offset 20, and we are going to set the middle value. So this should give us all 3 textures. And in the end we are going to calculate the x and y offset. This is actually the offset of the texture coordinates, and this is just at offsets 0 and 2 in the WOT file. So after getting all of these, we are going to have all of the information that we need to actually render this. So let's go under an engender C, and in here the first thing you will notice is that in our draw node we have got a integer which represents the actual texture we need to draw. We can set this to -1 if we want nothing, otherwise we are going to set that to whatever texture we want our draw texture to be, not the draw texture array but just the plain draw texture. And for the wall texture info, we have got, the reason we have got this is because we don't want to actually keep the whole wall textures here with our selves, because we that all data is not going to be needed. We can just transfer it to the GPU and that's it. However, we do need the width and height of the texture to calculate the texture coordinates correctly, so we're going to have those. So we're going to just store that in this separate structure, and as you can see we have got an array of that structure here for that purpose. And another thing we have got is I'm going to go here in our engine initialization function, and of course one important thing is that now we call the map function after loading all of the textures, because this needs the texture. So we're going to call this in the end naturally, and we pass it the textures and the number of all textures. And here when we are loading our textures, we allocate memory for the ball textures info as well, and we set that info width and height here correctly like we are supposed to. And that's pretty much it for the actual loading part. Now let's go under our mesh generation, and by the way first let's look at the engine render function. In here now for setting our flat texture array, we use the render set draw texture array function, and if our node texture is not equal to -1, then we also use the render set draw texture function and set that texture to the node's texture that we have got. And if it's -1, it will just leave it at default, and if it's not -1, then we are going to use it accordingly. So that's all pretty cool. And one thing we'll do is that inside of here, so I'm gonna go here where we are creating the floor node and the ceiling node. One thing we need to make sure is that we set the floor node for for this basic thing. We're for the floors actually we're gonna set the texture equal to the ceiling node's texture. So ceiling node texture, and we're gonna set that to -1. And this will basically prevent OpenGL from doing any expensive texture operations, because we are going to just not do it if it's -1. And actually we are going to do a very similar thing here as well. So let's just do it here. This is only for temporary, of course. We'll change this later when we add texturing for two-sided line defs as well, but right now we are only adding it for one-sided line def. So let's go here and take a look at it. So we use basic trigonometry, x and y. We have done this thing before in this series. We use basic trigonometry to calculate the width and height of our lines. And the reason we need this is because in Doom we have got like the texture coordinates are in the textures system. So like 0 to 32, if the texture is 32 pixels wide, then we need to make sure we convert that to OpenGL coordinates. For that we need the actual width of our line in world space, so we need that. And actually we need to do this before we scale that, in order to make sure that we get the width and height in Doom's coordinate system, not in our own. So we need to do this before scaling. Anyways, after that we calculate the minimum x and the minimum y value for our texture, and this is just equal to the offsets of the texture in the side def. And the middle texture, as I said, is the one that is used for our the one-sided line does. So we set the max x and the max y to, we first of all add our minimum x and minimum y, then we take the actual physical width of our line, divide that by the width of the texture. So this should give us the correct one. So for example, if our line is 64 units wide and the texture is 32, it will give 2, which means that the texture scale will look properly correct. And similarly we do the same thing for the height here, and we just use minimum y here. And when setting the vertices, we set of course the actual positions of the vertices, and we have got still texture index here, which is kind of unnecessary. Let's do that. And then we use minimum x and maximum y here. So when we set this, we need to make sure that this is set in the correct order. So in Doom, most textures are packed to the top, but that means is that the ceiling, so the ceiling is the one that at 0 0. So the start of the ceiling, which is actually the P3 vertex, is the one that has got both minimum x and minimum y. Then we have got for end x, we have got maximum x, and then for the floor we have got maximum y and maximum y here. But here we have got maximum x and maximum y according to whether it's end or start. So you just basically need to make sure that the what you use here corresponds to what you use here. And yeah, that's pretty much it. We need to just make sure we do that. And of course we need to set our nodes texture to wall texture with our side of middle, so we get the actual index of that. And yeah, that's pretty much it. We can use this and it should work correctly. So let's go ahead and run make right now, and what you should see is that while the other texture is the one that are the walls that are two-sided are not being displayed, however the one-sided textures are being displayed with the correct scale and everything, and you can see that it looks quite awesome. We have got like 8 textured world here. So you can see that we have got all of the textures here correctly, and of course we have still got colors in places of the two-sided ones, but we'll do that in the next video, so stay tuned for that. Make sure to like and subscribe as well so you don't miss the next one. Share this video with other people as well, and I'll see you in the next one.